Hi everyone, this is Ramalinga Prasad Kuppa. Welcome to my channel Pharma World. Today's topic is features on thin layer chromatography, that is TLC, as per USP 621 chapter. Let us see the requirement. In principle, TLC works on the same absorption and separation technique as in other chromatographic methods like GC and HPLC. The basic principle of TLC is similar to the other routine chromatographic techniques like GC and HPLC. The adsorption and separation happens with the help of stationary phase and mobile phase. The separation of components depends on the relative affinity towards the stationary phase and mobile phase. Depending upon the chemical structure and polarity of each constituent component of the compound, the affinity varies. More the affinity, longer the retention over the stationary phase and tends to move slowly during separation. Lesser the affinity, faster the elution, because it stays with stationary phase for less time. It is like a close relative stays longer in your house than your neighbor. It is the affinity or affection that plays here. The mobile phase moves up through the stationary phase under capillary action. So the mobile phase here moves up under capillary action. The mobile phase moves with pressure in other chromatographic techniques like GC and HPLC. During the elution of compounds, the compounds with higher affinity to stationary phase travel slowly while the others travel faster. So, as discussed above, the lesser affinity component moves faster than the higher affinity component. The constituents of compound appear as spots. Unlike GC or HPLC, the components appear as spots. If you see the peak of GC or HPLC in three-dimensional design, it appears like a cone. The cone looks like a circle from the top view. This is how the spot on the TLC plate should be understood. I hope that this is not too complicated explanation. Let us see the details of the technique. Stationary phase is a uniform thin layer of silica gel. The layer could be 10 to 15 microns silica gel particles. By meaning stationary means non-moving. So in the chromatography, the stationary phase is fixed and does not move. In TLC, stationary phase is a thin layer of silica gel on a glass plate. Commercial coated plates are also available in 20 into 20 centimeter sizes. Silica gel GF254 is a common stationary phase used for testing. They are more uniform and easier to handle for routine testing. Do you know what the meaning of GF254? It means the silica gel stationary phase is sensitive to 254 UV wavelength, and the spots that are not visible in the visible light can be seen using a UV viewing cabinet with 254 UV light in it. But be careful with the UV light chamber. Never stare with naked eye at the UV lamp when it is glowing. It can damage retina of your eye. There are variety of other silica gel powders. You can make the stationary phase layer on a clean glass plate with a spreader with required thickness of the film. But you need to be an expert to make the plates. Maybe after few trials you get good plates. But those days are gone. Now you get coated plates ready-made on thin aluminum sheets. For HPTLC plates, it is necessary to have coating with smaller particle size of about 5 microns. HPTLC is a faster version of TLC. You need a special equipment for the HPTLC test. Principally, the separation of components is same as in TLC. They separate by the relative polarity and affinity. Here you have an automatic scanner to determine the intensity of the spot by a computer system. Whereas in TLC the comparison is done with naked eye. The apparatus has a flat bottom tank of a suitable size with a fitting airtight lid. The apparatus is a rectangular glass tank with flat bottom. It has a lid with grounded edges. This arrangement is to seal the chamber airtight. This is similar to the lid of a desiccator. You have a ground glass seal which will be greased for making it airtight. This point is important. Unless the TLC chamber is closed tightly, the TLC results will not be satisfactory. You can have circular chambers also. For spotting the sample, a suitable PTFE coated flat-ended needle is required. This part is very important to get reproducible results. You should never use a pointed end syringe for the spotting. There is a possibility that the point can scratch the silica gel coating while spotting the sample solution. This problem will be less when using a flat end syringe. Also, the PTFE coated syringe would reduce the surface tension between the liquid and the needle. If there is no syringe readily available, there is an alternative. Take the capillary tube, hold the two ends carefully, expose the center of the capillary tube to a flame of a Bunsen burner. When the center portion becomes red hot, pull slowly the ends away. You get nice micron size pore at the center of the capillary tube. Cool it and just make a gentle click at the center. You get nice capillary tube syringe for spotting. It is not too hard to do this. You can try. Air dryer is required for drying while spotting the sample. The air dryer is required to dry off the solvent from the sample spot while spotting. Normal hair dryer can be a good choice. While spotting, care should be taken not to spread the diameter of the spot more than 5 millimeters. This can be achieved by spotting the sample solution in several smaller increments and drying to dry out the solvent. So, if there is a requirement to spot 5 microliters of a sample solution, spot slowly, carefully in 5 to 8 increments, drying every time to dry out the solvent. You get nice circular spots. Let us see the details of method of analysis. Prepare the chamber with suitable volume of mobile phase. Saturate the chamber with mobile phase. For reproducible results, the chamber air has to be thoroughly impregnated with the mobile phase vapor. This keeps the stationary phase from drying out before the process of elution is completed. For this, a suitable size of filter paper impregnated with mobile phase mixture spray and dress at least 2 inner sides of the chamber. But make sure that the filter paper is cut exactly to fit the sides of the chamber. It should not touch the TLC plate inside the chamber during analysis. The mobile phase evaporating from the paper saturates the chamber's air, so it does not dry the mobile phase off the stationary phase as quickly. Spot the sample as described in the earlier slide. Allow it to dry naturally for few minutes. Spotting of the sample or standard solution has to be done as prescribed in the previous slide. Allow the plate to dry naturally for few minutes. Generally 5 or 6 minutes would be okay. There should be a minimum gap of 10 mm for each spot. When there is a requirement to spot more than one sample, there should be at least 10 mm gap from one spot to the other should be maintained. For HPTLC, it could be at least 5 mm. The spotting should be done in such a way that the spot does not touch the mobile phase when placed in the chamber for elution. Generally, 10 or 12 millimeters must be sufficient, but it is necessary to make sure that the spots are above the mobile phase plane. Place the plate carefully into the chamber and close the lid firmly without any air leaks. Place the spotted TLC plate carefully without disturbing the tranquility of the mobile phase in the chamber and close the lid without disturbing the chamber. Allow the mobile phase to ascend up to at least 3/4 of the length of the plate. Allow the mobile phase to move at least 3/4 of the plate, but never allow the mobile phase front to move beyond the top edge of the TLC plate. After the elution is complete, remove the plate carefully. Mark the final level of the mobile phase front with a pencil and allow it to dry naturally. After the completion of elution, the plate should be removed carefully. Mark how much the mobile phase front moved with a pencil and allow it to dry naturally. This is required to measure the RF values of each spot. Retardation factor RF is specific to a particular spot. This is the ratio of the distance traveled by the compound and the distance traveled by the mobile phase. Unique feature of retardation factor is that it cannot be more than 1 because no spot would go beyond the distance traveled by the solvent front. Visualization of the spots as prescribed in individual monograph. All spots are not visible to naked eye. There are several methods prescribed in individual monograph to visualize these spots. Visualization can be visual or under UV 254 or 365 or exposure to iodine vapors or spraying some reagent solution over the plate. Most common non-destructive method is to visualize the spots in UV viewing chamber with 254 nanometers short wave light or 365 nanometer long wave light. The fluorescent zinc sulfide which is added in these GF254 TLC plates helps for visualization of spots. Precautions while viewing these ranges of UV are mentioned earlier. Always use safety goggles to view under these lamps. Never take these things for granted. It is a safety matter. Exposure to iodine is done by taking some iodine crystals in another closed TLC chamber and the plates are exposed to visualize the spots. After reaction with iodine, many compounds form yellow-brown spots with reaction with iodine. That is how the spots are visible. Some more compounds will react with spray solutions to form derivatives to appear as visible spots. For comparison test, the standard spot is taken as reference to determine whether or not the impurity is within acceptable limits. For routine reaction monitoring, TLC is the best method. This technique gives much faster results. Unlike HPLC or GC method, the results will be available within a very reasonable time. In such analysis, a spot of known concentration of standard is taken as reference and compare the test spot whether or not it is within acceptable range or limits. It is only a semi-quantitative limit test. Exact quantification is not possible in such situations. Quantitative measurements are possible by means of densitometer, that means the absorbance or fluorescence measurements. HPTLC would suit for such analysis very much. I hope the simple technique of TLC is understood well. If all these aspects are taken care, the TLC results are no less than HPLC or GC results. Look into your TLC test procedure and check whether or not all these features are included. Revise your system to meet these requirements for better results. Thanks for watching. For more videos, please do subscribe, like and share. Thank you.